When you look at the second diagram, you are required to prove that PQ is equal to Q sine y tan z over sine x. Now things may look strange to you because this is three-dimensional. This is said to be 90, it makes sense to you, but this is also 90. That's because PQ from this vertical plane is perpendicular to the plane QRS, and there's an axiom that says a line which is perpendicular to a plane is perpendicular to every line or line segment on that plane. So since it is perpendicular to QRS, it must be perpendicular to QR, which is a line on the plane. Now, it brings me to the point that I want to indicate. I know you may find in certain books that we use the sine rule in this triangle and also the sine rule in this one. But my take is, if it is right angled, there is no need really for the rules, because the rules are meant to help us when the triangle is non-right angled. Another thing, look at this, PQ equal to Q sine y tan z over sine x. How many angles are we talking about? We are talking about x, y, we are talking about x, and we are talking about z. So what I suggest you do, although methods differ, is that you look at x. This x is in a non-right angled triangle. You look at y. This y is in a non-right angled triangle. However, when you look at z, this is in a right angled triangle. So directly, immediately look for tan z. Immediately look for tan z. We look at tan z, okay, because the angle z is in a right angled triangle. Therefore, tan z is opposite over hypotenuse. In this case, your hypotenuse will be opposite the right angle. That's why it is PQ opposite over the right angle. Or rather, not over hypotenuse. Tan is opposite over adjacent. So it is PQ over QR. From which you make PQ the subject of the formula. Why do you make it the subject of the formula? What you ultimately have to prove has PQ on the left-hand side. So you put it on the left-hand side where it belongs. You have QR tan Z. Now, what we are talking about here, the Y and the X, are not in this triangle. So we need to come back to this triangle. We must involve this QR. One, it is what we call the link, because it links PRQ and RQS. When you get to the right angled triangle, you then apply the sine rule, and QR must be one of the sides you use. What is the angle opposite it? It is this one. That's why you have QR over sine Y is equal to, again, you don't need to choose any. Why don't I choose RS? Because there is no RS here. Why do I choose A? You are directed by what you have to prove. So you go to A, and the angle opposite it is this X. That's why you have A over sine X. And then we make QR the subject of the formula. Why do we make it the subject of the formula? I will explain to you in a short while. When you do that, you get A sine Y over sine X. So you go back to when we say PQ is equal to QR tan Z, and instead of QR, you put A sine Y sine X, which is what you were required to prove.